London, July 1858. The temperature has not dropped below 80 degrees in weeks. The Thames is low, slow, and the color of coffee. 3 million people live in this city. Their waste, all of it, flows into that river. The Houses of Parliament sit on the bank. Floor-to-ceiling windows face the water. Curtains have been soaked in chloride of lime in a last attempt to make the chambers usable. It does not help. The smell is so dense it has physical weight. Members of Parliament leave committee rooms mid-sentence. Benjamin Disraeli is seen crossing a hallway, clutching a handkerchief to his face, a stack of papers in the other hand. The press gives the crisis a name: the Great Stink. This is not a natural disaster. London has not been struck by anything. London has simply outgrown its own body, and the body is rotting from the inside. What happens next will save more lives than any medicine of the century, but the story starts much further back than you think. The toilet is ancient, not medieval, not Roman, ancient. In the ruins of Mohenjo-Daro in the Indus Valley, archaeologists have uncovered household toilets connected to covered brick drains. These are 4,500 years old, individual homes, running drainage. The engineering is clean, confident, deliberate. We did not improve on it for most of the time since. The Romans made it social. Public latrines in Rome sat 20, 30 people side by side. No partitions. You went, you talked, you made deals. It was a place for gossip and negotiation as much as anything else. When you were done, you cleaned yourself with a shared sponge on the end of a stick, rinsed in a trough of running water. The sponge had a name: tersorium. It was communal property. There is no evidence that anyone thought this was strange. Beneath the streets, the Cloaca Maxima, the Great Sewer, carried the city's waste into the Tiber. It was built in the 6th century BC. Parts of it are still standing, still functional. One of the oldest engineered structures on Earth. Then Rome falls, and so does the plumbing. Medieval Europe is a sanitation catastrophe. Chamber pots emptied from windows, streets running with waste. The custom of shouting, "Watch the water," before throwing the contents of a pot into the street below may be the origin of the English word loo, or it may not. Nobody is certain. What is certain is that for roughly 1,000 years, the Western world forgot how sewers worked. In 1596, a man named Sir John Harington, courtier, poet, godson of Queen Elizabeth, builds a flush toilet. He installs one in his own home and one in the Queen's Palace at Richmond. He calls it the Ajax, a pun. In Elizabethan slang, a jakes means a toilet. Elizabeth uses it. She reportedly likes it. Nobody else builds one. The idea disappears for 200 years. In 1775, a Scottish watchmaker named Alexander Cumming patents the S-trap, a curved pipe that holds a small amount of water, creating a seal that prevents sewer gas from rising back through the drain. It is a tiny, elegant invention. It is in the pipe under every sink and toilet you have ever used. And then there is Thomas Crapper. He did not invent the toilet. He was a plumber in Victorian London who successfully marketed improved flushing mechanisms. His name on manhole covers throughout the city is one of history's more satisfying coincidences. The word crap predates him by centuries. Now, London, the 1800s, and the clock starts ticking. In 1800, London's population is roughly 1 million. By 1858, it is 3 million. The city has tripled in 60 years. Industrial revolution, migration. Every one of those 3 million people produces waste, and the waste goes into cesspools, brick-lined pits beneath houses, meant to be emptied by night soil men who cart the contents away. By the 1850s, there are an estimated 200,000 cesspools in London. Most of them overflow. Then the flush toilet becomes popular. The cesspools fill faster. The overflow runs into street drains. The street drains empty into the Thames. The Thames becomes an open sewer. People start dying. Cholera moves through the city in waves. More than 6,000 dead in 1832, 14,000 in 1849, 10,000 in 1854. Each epidemic worse in some quarters than the last. Nobody understands why. The dominant theory is miasma, bad air. Disease comes from smell. If you can smell it, it can kill you. Remove the smell, remove the disease. This is what every authority in London believes. In 1854, a physician named John Snow disagrees. Working in Soho during the latest outbreak, Snow maps the deaths. They cluster, not randomly, around a single water pump on Broad Street. Snow traces the contamination to the well. He persuades the parish to remove the pump handle. The deaths slow. Snow publishes his findings. He argues, carefully and with evidence, that cholera is waterborne, not airborne. The medical establishment ignores him. Snow dies in 1858, the year of the Great Stink, without seeing his work accepted. Here is the irony that sits at the center of this story. Snow was right. Cholera lived in the water. But the solution London eventually built was not designed to clean the water. It was designed to remove the smell. The engineers believed they were clearing miasma. They were actually removing the pathogen. They got the right answer for the wrong reason. June 1858. The heat does not break. The river bakes. The smell reaches a pitch that stops the business of government. Here is the political arithmetic. Cholera had been killing Londoners for 26 years. Nobody with power had done anything structural about it. The disease hit the East End, the tenements, the docks. It killed the poor. The poor did not sit in Parliament. The smell hit everyone. 18 days. That is how long it took from the worst of the stink for Parliament to pass the bill authorizing the Metropolitan Board of Works to build a new sewer system for London. 26 years of cholera. 26 years of reports and committees and hand-wringing. 18 days of discomfort for the powerful, and the money appeared. The man who built it was Joseph William Bazalgette, chief engineer of the Metropolitan Board of Works, meticulous, methodical, given the largest civil engineering project in the world, and he delivered it. The plan: intercept the sewage before it reached the central Thames, run massive new tunnels along both banks of the river, capturing the outflow from every street drain and cesspool in the city, carry it east, past the population, and release it downstream where the tidal flow would take it to sea. 82 miles of intercepting sewer, 1,100 miles of street sewers feeding into them, 318 million bricks. The tunnels were egg-shaped in cross-section, narrow at the bottom, wide at the top, not for aesthetics. At low flow, the narrow base concentrates the water, keeping the channel self-cleaning. At peak flow, the wider top provides the capacity. It is an elegant solution. It is still in use. Bazalgette used Portland cement, one of its earliest large-scale applications. He tested every batch himself before it was laid. And then he made the decision that would matter more than any other in the design. He calculated the diameter the sewers needed based on London's current population. Then he increased it, substantially. His reasoning, as it has been passed down, we're only going to do this once, and there's always the unforeseen. London's population would nearly triple over the next century. Bazalgette's sewers handled it. They are still handling it now. The construction also gave London its embankments: the Victoria Embankment, the Albert Embankment, the Chelsea Embankment. 52 acres reclaimed from the Thames. The river narrowed. The sewers went under the new land. London's waterfront was transformed. Work began in 1859. The main intercepting sewers were operational by 1865. The full system was complete by 1875. Total cost? More than £4 million. Hundreds of millions in today's money. The last major cholera outbreak in London was in 1866. It struck the East End, the one area not yet connected to the new sewers. Once the system was fully operational, cholera did not return. Not reduced, gone. Life expectancy in London in 1850, roughly 37 years. By 1900, over 45. A decade of life gained in half a century. The single largest contributor was not a drug, not a vaccine, not a surgical technique. It was sanitation. The design spread. Paris modernized its sewers in the 1860s. Hamburg rebuilt after a devastating cholera outbreak in 1892. New York, Chicago, Boston, all constructed intercepting sewer systems modeled on London's. Here is the number that reframes everything. In the 19th century, clean water and proper sanitation saved more lives than all of medicine combined. More than vaccination, more than surgery, more than any pill. The toilet and the sewer pipe, correctly engineered, were the single most important medical intervention of the modern era. And almost nobody thinks of them that way. Today, 3.5 billion people worldwide still lack access to safely managed sanitation. That is a United Nations figure. The technology that saved London is more than 150 years old. It is proven, it is not complicated, and for nearly half the human species, it does not exist. Bazalgette sewers run under London right now. Rush hour passes above them. Parliament sits beside the river they cleaned. The tourists on the embankment walk on land that Bazalgette built on top of the Thames. Almost nobody knows his name. There is a small plaque on the Victoria embankment wall near the river. If you know where to look, it reads his name. Below it, the Thames flows clean enough that salmon have returned, for the first time in more than a century. The smell that once stopped a government is gone. The man who removed it is mostly forgotten. And the system he built, quietly, precisely, deliberately oversized for a future he could not see, is still carrying the city's waste to this day. Some of the most important things in the world are the ones you never have to think about. That is the whole point.